Alright, hello again and welcome back to Emory Board Productions. We're going to move a little bit away from the elementary addition that we've been using, showing how counters and C-rods can help our kids use concrete manipulatives to build on their action language and come up with answers. And our logical progression is not going to be subtraction, as has been widely thought for many decades in the math world as the way to go after addition with small kids. We're going to go more logically to the basics of multiplication, which through repeated addition actually has more logic and gives kids more of a building block to take what they already know and build on to further their math concepts. Let's start with a simple example. Again, we're back to the dive boat on the west side of Maui, this one the Endeavor, and the Endeavor takes 4 divers on 4 dive trips each Monday, Wednesday, and Friday. And the question is, how many dives does Endeavor go on each week? Well, what we're going to learn now through a repeated addition is that we also use action language for that, and that action language is going to manifest itself in the term sets of. And you'll see that that will come in really, really handy as we continue to work out problems like this. And I didn't write it very neatly, but it's sets of. And for instance, in this example, we decide that the number sentence needs to be 3 sets of 4, and the math sentence that you'd see most commonly in books in the standard algorithm is simply 3 times 4. The answer, as we know, is 12, and the meaning is going to be 12 what? Well, it's going to be 12 dives. Okay, and let's go on and see a little bit how that jives with what we know with our manipulatives, in specific the C-rods. As you can see, our little key here at the bottom. Once again, the kids already have this memorized by the time they've seen 3 of these videos. But let's see how we would go about building our little train tracks with what we know here. We're taking the action language of 3 sets of 4 dives and trying to come up with a number. Now, since we don't have a Cuisenaire rod that equals 12, the kids are going to figure out just as soon as can be that it's going to be one set of 4 joined with another set of 4 joined with another set of 4, and then they've made some train tracks, and they're going to find out that the only way they can find an equivalent number to explain that whole problem to them is to take their largest number and try and make it, or see where it comes out to, and then they're going to figure out that what they really need is a 2 on top of that to make it equivalent. And so there they have figured out that there are 12 dives. In all. But let's go back just a little bit so that we understand it as teachers. We have selected sets of as the language that we're going to use for basic multiplication or repeated addition. And in this case, we had to decide, well, what are we talking about? Is the 3 days the sets or the dives the sets? And so we can just simply go back to the beginning problem and realize what they're asking for is how many dives. And that's going to give us the key in terms of knowing where to put which number in this language. We need it to be 3 sets of 4 dives in order to come up with the solutions that we said were meaningful, or 12 dives. Eureka. Tune in again to Emery Board Productions, and we'll talk more about repeated addition and go further with the logic behind using action language. You never learn anything in the abstract. You only build on the things that you already know. Thank you.